Today's problem is word ladder, which is a hard problem on LeetCode. Basically, you have to go. The whole description states that you have to go from the word hit till cob using the words given in the word list array, and each transformation costs us one unit. Basically, the first you will go from hit till hot, hot then dot, dot, dog, and then cob, which is 5 words long. One, then two, then three, then four, and basically the five. The uh, you can say the criteria of going from one word till the next word is basically if they are differentiated from the next word by one single letter. For example, the hit and hot, there is a difference of single letter. H and T remain constant. I and T are different, and same is the case with hot and dot. Hot, the O and T remain constant, and H and D are basically the variable. Basically, is the difference in character. And same is the case with every one of the transformations. This is stated here. Basically, you have to return the shortest transformation sequence. Uh, 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 Basically, if you have already solved some of the problems, you can easily identify this as a graph problem because there is nothing special. There is nothing special. There is no there is no trick, or you can say this is straightforward graph problem. Is you have already solved some of the medium, you can say, problems on LeetCode regarding graph and regarding BFS. The question here is main to basically use DFS or BFS. The I'll just state something very important regarding the graph traversal techniques. If you want to get the shortest something, or do something minimum number of steps, you have to always use a BFS, because because BFS visits the nodes of the graph in sequential manner, one by one. First, you can say the first ladder, the first order, then the second order, and the third order. You are always guaranteed. If you visit the nodes in a BFS manner, you'll always guaranteed that the node visited would be you can say in the shortest possible time. I'll just paste something here. Number of words in the shortest transformation sequence indicates BFS and not DFS, because DFS, you can say, DFS first explores the single branch till the end, till the leaf of the, you can say, till the end of the recursive branch, and then all the basically a single recursive branch, and then you can say go backtracks and explores another branch. But BFS explores all the, you can say, neighbors, all the neighbors sequentially. BFS gives the shortest path because it will visit the node in sequential manner, level by level. And for example, if you should the prereq for this problem should be, you can say, a basic understanding of how the BFS works, and basically basic code of how you can basic code of BFS. I'll you or you will be wondering how what will be the neighbors of the current node. This is a root node. The begin word is a root node. Basically the not the root node, basically starting node, and end word is the, you can say, final stage of our sequence. The neighbors of hit are all those words which differ by a single character. For example, hit hit to hot, only O differs. All the words like get, only O differs, and the remaining H and T remain constant. All the words like get and hip, for example, all the words like get, but in get only H and G are different. In hip only hip only T and P are different. Would be neighbors of the if they are present in the word list. All the variations of the current word, if all the of the current word, if they are present is if they are present in this array, would be basically the neighbors of the current node. And each changing character would, no matter the place, would cost us one unit. For example, the hit, get, and hip, both would cost us a single unit of time if we during the transformation sequence. all you can find plenty of videos on the internet that describe the simple BFS approach. But I thought I would be I would write the basically I would write the code using the bidirectional BFS. First, I would describe something like from something the basics of bidirectional BFS, so you can get along with me. You can always use a bidirectional BFS when both start and end states are given. In this case, the begin is the begin word is the hit is the start word, and cog is the final stage. So this indicates we can use a bidirectional BFS. By the it is not a must for coding interviews, but it is a good thing to know. And you can say this is a quite you can it is a quite advanced topic. The problem on lead code, this problem, open the log. It is basically almost as the same as this problem, but it is a medium problem. Directional BFS approach in using something like something this on the simultaneously, something like this. Do BFS from the source in forward direction and the target in backward direction. If this is the start node, and which are in our case is the begin word, we will do a forward search from this side and a backward search from this side. They will meet something for example, they will meet somewhere in the middle, and this will save us basically quite a lot of time. Every iteration we choose a smaller queue for the next iteration. I'll just explain during the code. The theory behind using a bidirectional BFS rather than a single directional BFS is basically this. As you go deeper, the cost of exploring exploring a single layer increases exponentially. So instead of doing a single BFX and exploring all the layers, we basically do half half def BFS, which saves a lot of time. Intersection point somewhere in the middle. For example, here and here, this edge could be the intersection point, and this would save us a lot of time rather than if we would have started from A and would be, which we could which we must go to the O to basically reach the end state. In this case, we will meet somewhere in the middle using the bidirectional BFS. Time complexity for you can say bidirectional BFS is this. And the time complexity for you can say this the single BFS, you can say the classical BFS is this. But we basically this is the TC for the single BFS. But for the bidirectional BFS, this is a time complexity because we run two BFS simultaneously, one from back, one from the forward direction, and they meet somewhere in the middle. So we are not exploring all the layers. This is why time complexity is which is far less than this. I'll just cut and paste this. We will need you can say three sets. Using hash sets. We will need a begin, you can say a forward set. You can say forward set which we will need you to basically uh, for the forward direction, and there will be a backward set, and we will also need a scene set. The forward set would contain the begin word, and the backward set would contain the end word, and the scene would also contain the scene would also contain the begin word, because this is the starting point of our you can say BFS. We will also convert the word list into a set for you can say better access times and something like this. Okay. Now we will basically we will basically start a while loop till the both forward set and backward set are present, something like this. Now I'll just there's something else to do. In this case, I just said every iteration we choose a smaller queue for next iteration. Smaller queue or smaller set, same thing. Every iteration because We will choose between the forward set or backward set. If the forward set has if the forward set has less number of elements, we will basically swap the both the sets. So we could go with the smaller number of elements and basically improving the efficiency of our code, something like this. If this length is greater than this, if the length of the forward is greater than the backward, we will simply swap the, you can say, sets. In Python, you forward set, something like this. Okay. Now we have the node swap for us. We will always be going through the we will always be swapping, and you starting with the node, we starting with the set which is smaller number of nodes to improve our code's efficiency. Now we need another set. Begin set. This would contain the, you can say, basically all the transformations of all the transformations. Now we can simply go for example like this, forward in the this. No, I did the swapping wrong. This would be this. You have to basically set the backward set, to set the backward set here, something like this. If length of forward set is greater than backward set, set the backward set to for as the forward set. Backward would be forward, forward would be backward. Now it's correct. For word, we will traversing all the words in the forward set, and something like this. For word in word set, and for x in range of you can say word. There are multiple ways for pre-processing, but I would be going with the simplest approach, for something like this. For character in, we have to basically we there are multiple ways to generate multiple ways to generate all the neighbors of the current node, as I explained earlier. All the words which have a single character difference from the current word would be all the would be, and they are present in this word list, would be neighbors. Hit hit and hot hit and hot the hit hot is a neighbor of the word hit. And basically there are multiple ways to generate all the neighbors. I would be going through the approach. For example, we would be going through the first place hit, and we would try basically all the, you can say, characters in the character. We would be traversing all the characters in the alphabet, all the alphabets in English language. For example, A, B, C, and C. This is it, AIT, BIT, CIT, DIT, and then for the we can say second, and then H would remain constant, and HAT, then HBT, something like this. I hope you understood me. Okay, I'll just simply now we creating all the words of the the using by something using a slicing, something slicing. Start. This means start. From start we would be slicing till x, and then we would be appending the current character. Then we would be slicing till the you can say x plus 1 till the end of the string. This would give us hit all the neighbors of the, you can say, with a single letter difference. If tmp is equal to, you can say, if tmp in you can say if tmp in the end set, backward set, so basically we will simply return distance distance plus 1. Okay, or else simply, there's a problem with the indentation. If this word is in the backward side, for example, we started searching, and we found this, we found our end, we have one end state. We would simply return the distance. Else, if tmp in word list, basically if tmp in word list and tmp not temporary word not in scene, we would scene dot add tmp, scene dot add tmp and temporary word, and something like, we will also add this word in our current set tmp. Okay, and for, if our while loop ends and we found nothing, so we'll simply return 0. And one more thing, we will also need, basically, if to check if the to check if our end word is in word list. If our not if not a, in a, if our final stage is not but basically this is an invalid, you can say invalid input. So we will be, this is a boundary condition, not in word list, return 0. If end word not in word list, we will this would basically swap, this would basically swap the number of, you can say, this we would always go with a smaller number of hash set. And in the end, we will need to increment our distance variable, and also assign this set as a new forward set, this plus 1 and begin. I hope it should work. I'll just start run code, and if it's properly runs, I'll then explain the code once again. Distance variable, initializing the distance variable with 1. It's running properly. Okay. The code is submitted successfully. I'll explain the approach once again. You need two sets, one forward set, one backward set. The forward set will contain the initial stage. The you can say backward set would contain the, you can say, final stage. Also need a scene. You also need a scene. You can start going through all the words you have basically previously traversed, previously seen. And this would contain us this would contain our, basically, initial stage. The word we have converted this set word list into a, this was previously a set, previously a array. We have converted this to set for better access time, better access times. And this is the distance variable we will for the use with returning here. This is basically the boundary condition. We basically the boundary condition for checking if the end word is not in word list. We don't need all this processing. And if basically we will basically we will basically using a while loop will basically traverse basically we're using a while loop will BFS using the smaller number of nodes that would basically increase our efficiency efficiency because we will always going we will always exploring less number of you can say nodes and its and basically less number of branches. This is the set for you can say exploring the current transformation, and for each wording for this we were going over each basically place hit then h for in hit first h then I then t, and we will be replacing h with all the characters in the alphabet in all the alphabets in the English language, which are 26. We would form basically you can say temporary word. If the temporary word is in backward set, that means we have reached the final state, which should be initialized here. We would return distance plus one. And if the temporary variable is in word list, basically it's a valid number, and it has not been previously seen. Then we would add it a scene set and also a begin set. We would assign the begin set in the next iteration. We would assign a begin set to our forward set, and it also increment our you can also increment our distance also increment distance variable with plus one.